Today we're going to watch our first video of class notes. We're going to talk about the properties of numbers. And we have the tables here already copied down the definitions. We're going to fill in the name of the properties, symbols, and the examples. So first property, any quantity is equal to itself, is called the reflexive property. Now, symbols. That means we're going to use algebra to describe it here. So that means A is equal to A. Put a little tail on that. It look like an A. Examples. 7 equals 7. It always equals the same thing. We could also look at it as an expression. 2 plus 3 is the same as 2 plus 3. It's always the same. That's reflexive property. Next one. One quantity equals a second quantity, and the second quantity equals the first. That is our symmetric. Symmetric. Algebraic example. If A equals B, then B would equal A. Okay? Anytime A equals B, then B is always going to equal A. So your example here, you can look at it as an equation. If 9 equals 6 plus 3, if you see 6 plus 3, you know you can plug in a 9 there. Next property here. If one quantity equals a second quantity, and the second quantity equals a third quantity, then the first quantity would equal the third quantity. That's our transitive property. Our example here. If A equals B, again, and B equals C, then A would also equal C. So if A equals B and B equals C, then A would have to equal C as well. So if 5 plus 7 equals 8 plus 4, those are the same. And 8 plus 4 equals 12, then 5 plus 7 would also equal 12. So you can look at it that way. These are all transitive to each other. And 7 plus 5 equals 12, and 8 plus 4 equals 12. That means 5 plus 7 is equal to 8 plus 4. The last property of equality is a quantity may be substituted for its equal in any expression. That's the substitution property. Substitution. If A equals B, then A, right, may be replaced by B and any expression. So A equals B, then anytime we see in A, we can plug in B. We can plug that B in. Example, if N equals 15, then 3N would equal 3 times 15. We can substitute that in. Now we're going to look at some properties dealing with addition and multiplication. Some of these are the same for both addition and multiplication. For our addition properties, for any number A, the sum of A and 0 is A. That is our additive identity property. I'm sorry for my hand, but it's really hard to write on the smartboard here. Symbols. So A plus 0 equals A. A plus 0 is going to equal A. Example, 7 plus 0 equals 7. Anytime you add 0 to something, you get what you start with. That's our additive identity property. A number and its opposites are additive inverses of each other. That's our, in the definition, additive inverse property. Inverse. So A plus negative A equals 0. That would also work for A minus A, because subtraction is really adding a negative. It's adding a negative, right? You can change subtraction into addition, but changing that subtraction sign to addition problem and making it a negative. So we have 6 plus negative 6 equals 0. That's the inverse of each other. Multiplication properties. For any number A, the property of A and 1 is also A. That's very similar to this one right up there, right? For addition, right? It's the same sound. So that's our multiple identity. Our multiplicative identity. So, on this one, A times 1 equals A. Anything times 1 gives you that same number. 13 times 1 is equal to 13. That's our identity property here with multiplication. For any numbers A and the product of A and 0 is 0. Is our multiplicative property 0. I'm going to abbreviate multiplication here out, MULT. Property of 0. So A times 0 is equal to 0. Anything times 0 is 0. 8 times 0 is equal to 0. Our last multiplication property, for every number A over B, where A and B not equal 0, there's exactly one number, B over A, such that the product of A over B and B over A is 1. Sounds very confusing. It's not too hard. It's actually kind of like this one up here. It's going to be our inverse property. Right? We are multiplicative inverse. So what we're saying here is, if we have A over B, and we multiply that by the inverse here, B over A, we get 1. Our examples here. So 2/3 times 3 over 2 equals 1. A lot of times we see this still with whole numbers. 5 times 1/5 equals 1. Because 5 is really 5 over 1. So 5 times 1/5 is equal to 1. We have 2 more properties. Commuted and associated. These work with both multiplication and addition. Right? The order for the commuted property, the order in which you add and multiply numbers does not change their sum or product. So our symbols here, what we write out algebraically for this, A plus B is the same as B plus A. I can switch the A and the B around and it will not affect the sum. Likewise, I can multiply A times B, which is the same as B times A. My product does not change if I flip the numbers around. Give ourselves some examples. 3 plus 5 is the same as 5 plus 3. And 6 times 7 is the same as 7 times 6. It's my commutative property. The associative property is the way that you group 3 or more numbers when adding or multiplying does not change their sum or product. Once again, this works for multiplication and addition. Algebraically looking at this, you have A plus B plus C. We can add the A and the B first, then add the C, or we could add the B and the C first, and then add the A. We would get the same answer. That's my associative property for addition. Multiplication works the same way, A times B times C. I can either go A times B first, or I go B times C first. I get the same answer no matter which one I do it, whichever grouping I do here. Examples: 2 plus 6 plus 4. 2 plus 6 is 8, plus 4 is 12. I change it around and do 6 plus 4 is 10, plus 2 is 12. Same thing can work for multiplication. 2 times 3 times 5. 2 times 3 is 6, times 5 is 30, or 3 times 5 is 15, times 2 is also 30. So those are our properties here we're going to look at. Now to practice. Now we're going to name the properties using step. When we simplify our expression, we're able to do this because of the properties that we have mapped, because these certain rules exist. So we have our expression here. We move from this expression down to here. What property did we do? Well, look at what changed. That changed. It went from 4 times 2 to an 8. That was a substitution. We substituted in. 4 times 2 is equal to 8. It's the same thing. We substitute that in there. Next, look at what changed here. We had 8 minus 8. It went down to 0. Remember, we're like adding the opposite here. That would be our additive inverse. Next step, we're going from 2 times 3 to 6. We're not changing orders or anything, okay? So that is another substitution. We're saying 2 times 3 is equal to 6. We're going to substitute in 6 where we see the 2 times 3. Lastly, so 6 plus 0, that is additive identity. When I add 0 to something, it stays the same. Go ahead and make sure you try these ones on your own. Pause it here, try and fill them out, and then check your answers here. First one, 15 divided by 3 gives us 5. That's a substitution. Next, we're going 5 minus 5 in the parentheses is 0. Added by inverse. 7 times b 1/7. That's multiplicative inverse. 6 times 0 is 0. Multiplication property of 0. And 1 plus 0 is 1. Additive identity. And that is it for our notes here today.